The universe, a vast and mysterious expanse, not only houses our solar system, but is also home to billions of other planets. Each one a unique, untold story waiting to be discovered. Among these worlds, could there be one like Earth, where life might take root? With the advancement of technology, following the success of Kepler, the TESS telescope was launched in 2018. With its ability to survey 85% of the sky and focus on nearby bright stars, it has ushered in a new era of searching for planets with Earth-like conditions. TOI 700d, a planet similar in size to Earth and located within the habitable zone of a red dwarf star, could be a strong contender for supporting life. Meanwhile, the planet Teegarden b, with the highest Earth similarity index, is sparking curiosity among scientists about the adaptability of life under extreme conditions. However, not all exoplanets promise life. Some planets, like Trappist-2b and 55 Cancri e, possess extreme conditions that render them into what could be described as death planets. Now, let's embark on a journey to uncover the fascinating secrets of these exoplanets. The first and most essential tool in shaping our understanding of distant planets is Kepler. Launched into orbit on March 7, 2009, Kepler was not just a telescope. It was a massive light-measuring machine designed to observe a single section of the sky continuously for nearly a decade. This method relies on a highly refined physical principle. When a planet passes in front of its parent star, it dims the star's light by a fraction, sometimes as little as 0.01%, equivalent to detecting an ant crossing a car's headlights from a distance of 100 meters. Kepler proved that small, Earth-like rocky planets were not anomalies, but rather the rule across the galaxy. With more than 2,600 confirmed planets, Kepler accomplished its mission, providing undeniable statistical evidence of the commonality of other worlds. We found them, but what exactly are they made of? If Kepler was the hunter searching for numbers. The Transiting Exoplanet Survey satellite, launched on April 18, 2018, took a different approach. TESS doesn't aim to look far. Instead, it focuses on nearby. Bright stars and surveys a wide swath of sky. As of now, TESS has confirmed over 390 exoplanets and created a list of over 6,600 potential candidates. Notably, TESS discovered the Trappist-1 system, shifting the scientific focus from simply proving existence to searching for signs of life. chemical traces in atmospheres by concentrating on brighter, nearer stars within just 200 light years. This strategy is crucial. The closer and brighter the star, the easier it becomes for scientists to use giant ground-based telescopes to take the next step, analyzing the atmospheric properties of exoplanets. With its ability to cover 85% of the sky, TESS scans the entire galaxy in segments, like constructing a grand mosaic. By finding planets orbiting cool, stable dwarf stars, TESS has discovered the first candidates that resemble Earth in size and conditions, located within the Goldilocks zone of their parent stars. The combination of these two missions not only expands our horizons, but also allows us to probe the light passing through planetary atmospheres. A breakthrough that could reveal chemical signs of life known as biosignatures. Among the worlds uncovered, which one truly meets the criteria for fostering life as we understand it? Could the Goldilocks zones hold the answer to the question of our loneliness in the universe? If missions like Kepler and TESS have been successful in identifying thousands of new worlds, then within this vast array of planets, where can we truly find an Earth-like world, where the story of life might begin to unfold? We began searching for worlds not only existing, but also potentially habitable. This is where the concept of the habitable zone, also known as the Goldilocks zone, becomes our guiding principle. The real-world statistics present a shocking and somewhat concerning truth. Most Earth-sized planets discovered orbit red dwarf stars, specifically M-type stars. These stars are the quiet giants, accounting for about 75% of all stars in our galaxy. Since red dwarfs are faint and cold, their Goldilocks zones are pushed close to the star, bringing these planets closer than Mercury is to our Sun. Due to their tight orbits, these Goldilocks worlds are almost certainly tidally locked, with one side perpetually facing the star while the other remains in constant darkness. In their early stages, M-dwarfs often flare up, sending out X-ray and ultraviolet radiation storms that can be 100 to 1,000 times more powerful than our Sun's storms. This high-energy radiation has enough power to strip away the atmospheres of these planets, breaking down water into hydrogen and oxygen and ejecting them into space within just a few million years. Even if life were able to take root on these planets, Could it survive the constant barrage of radiation? One such candidate is the planet TOI 700d. Discovered in January 2020 by NASA's TESS mission. It orbits the quiet red dwarf star about 102 light-years away. The quietness of its host star is a key factor, as it significantly reduces the threat of destructive superstorms compared to other M-dwarf systems. TOI 700d is Earth-sized, about 1.19 times Earth's radius, and is at the perfect distance to complete an orbit in just 37.4 days. It receives about 86% of the energy Earth gets from our Sun. This leads to a theoretical equilibrium temperature that is frozen. However, the actual surface temperature entirely depends on the composition and density of the atmosphere. Early climate models have suggested three main scenarios. A thin, Mars-like atmosphere that would cover the planet in ice. An Earth-like cold atmosphere with potentially frozen oceans. A dense carbon dioxide atmosphere, a primordial atmosphere rich in carbon dioxide. Could create enough greenhouse warming to raise the surface temperature above 0 degrees Celsius, allowing liquid oceans to exist. If the third scenario proves true, TOI 700d might be a warm ocean world. Even though it remains tidally locked, this makes it a prime candidate for atmospheric analyses to search for biosignatures. Another intriguing world is Teegarden b. Orbiting the ultra-cool red dwarf Teegarden, only 12.5 light-years away. Teegarden b holds the highest Earth similarity index, around 0.95. The ESI is a complex measure based on radius, density, escape velocity, and equilibrium temperature, indicating that this planet is almost a perfect physical replica of Earth. This planet has an extremely short orbital period, just about 4.9 days. However, due to its dim star, it receives heat that's very similar to Earth's, leading to an estimated ideal surface temperature. With such a short orbital cycle, Teegarden b is strongly tidally locked. The greatest challenge for life here would be the stability of the horizon zone. One side is perpetually in daylight, and the other side is locked in eternal darkness. The biggest challenge to life here would be surviving the extreme conditions on both the day side and the night side, freezing cold. Life could take the form of microbial communities beneath the surface, like Earth's fossilized life forms. Black sea plants evolved to absorb the faint infrared light of the M star. Organisms moving along the ideal temperature strip of the horizon zone as the planet orbits its star. Detailed analyses of TOI 700d and Teegarden b show that the Goldilocks zone is merely a necessary condition. The true recipe for habitability is the complex interaction between the planet's atmosphere, the parent star's activity, and the adaptability of life itself. We stand at the pinnacle of an extraordinary discovery. Could TOI 700d be a warm ocean world heated by carbon gases? Or is Teegarden b a sanctuary for a resilient biosphere? The exploration of exoplanets has revealed a shocking truth that challenges our imagination. The universe is not limited by the rules we know. Strange worlds exist in the far corners of the universe, where physics and chemistry are turned upside down, and life could evolve in ways we never imagined. One such world is Gliese 1214b, an ocean super-Earth located 48 light-years away. The planet orbits very close to its host star, causing surface temperatures to fluctuate between 120 degrees Celsius and 280 degrees Celsius, a heat so intense that water would instantly evaporate without a thick atmosphere. Under these conditions, water cannot exist in liquid form. Instead, it compresses into strange forms of ice, like Ice Vi or Ice X, which are crystal structures that can exist at temperatures far higher than water's boiling point on Earth. So, what happens under these conditions? Could there be a layer of liquid water between the vaporous atmosphere and the high-pressure ice layer? This raises the intriguing possibility of life in a completely different environment than we ever imagined. Gliese 1214b challenges us to rethink life itself, igniting curiosity about how life could exist in such extreme conditions, unlike anything we've seen on Earth. Wandering planets, which are not bound to any star, introduce a dramatic shift in our understanding of habitable environments. Y0855-0714. A planet with surface temperatures ranging from -48 degrees Celsius to -30 degrees Celsius, is nearly completely isolated from external heat sources. What has kept water stable on this planet despite it not receiving light or heat from a star? The answer may lie in two sustained internal energy sources. The continuous decay of radioactive isotopes like uranium, thorium, and potassium-40 in the planet's core, alongside leftover heat from the planet's formation billions of years ago. These energy sources provide a stable heat supply, enough to sustain a hidden liquid ocean, dark but warm beneath several kilometers of ice. Life on these planets might not rely on photosynthesis like on Earth, but rather on chemosynthesis from hydrothermal vents at the ocean floor. Microorganisms here could endure extreme conditions, completely separated from light and solar energy. This makes us rethink life in the universe and expand our definition of what life can be. These bizarre planets, like Gliese 1214b and Y0855-0714, not only challenge our old definitions of habitable environments, but also make us reconsider the possibility of life existing under physical conditions that were previously unknown. The questions raised about survival in these extreme environments are not just changing the way we understand life, but they are also showing us that the vast universe could harbor creatures unlike anything we've ever known. Life may not only exist where there is liquid water and sunlight, but also in places where these conditions are entirely absent. These discoveries remind us that in the universe, life isn't always what we know. And the search for life may not be just about finding Earth-like conditions. Instead, we may find creatures that have evolved in completely different environments, in places where the conditions we consider essential for life may not even exist. In the relentless quest for life, every discovery of a hostile exoplanet serves as a chilling reminder of nature's cruelty. These worlds are natural laboratories of annihilation, where the laws of physics are twisted, where matter melts, tears apart, and is irradiated down to the atomic level. The death planets are where we witness the greatest brutality of the universe. TESS-2b is one of the most astonishing of these. It is the darkest planet ever discovered, a literal black hole in the fabric of space. TESS-2b absorbs an astounding amount of light from its parent star. Imagine, it's darker than any form of charcoal or synthetic material ever created on Earth. What fuels the endless curiosity about this world is the optical paradox it presents. The planet is tidally locked, rotating so close to its star that its day side reaches a searing 1,000 degrees Celsius. It's like a smoldering ember in eternal darkness. A major physics question arises. What in the atmosphere of TESS-2b could be responsible for such absolute light absorption? Could it be the presence of sodium and potassium gases in an ultra-hot state, broken down to create this incredible light-absorbing ability? Might this phenomenon be replicated by humanity in the future to create super-absorptive materials? Even more dreadful is the atmospheric dynamics at play. Winds on HD 189733b reach speeds several times that of sound and are fast enough to circle Earth in mere hours. These molten glass droplets don't fall straight down, but are swept horizontally by supersonic winds, turning the atmosphere into a massive shredder. What keeps such a dense, silicate-laden atmosphere moving at speeds far beyond the aerodynamic limits we know? Some planets challenge us by transforming matter under unimaginable temperatures and pressures, while others provide us with a rare glimpse into the death of a world. 55 Cancri e was once dubbed the Diamond Planet due to its abnormally high carbon content. It is a tidally locked super-Earth with extreme day and night temperatures. The daytime side of this planet reaches temperatures so high that it melts most metals and silicate materials, creating a liquid magma crust. Meanwhile, the night side still maintains a staggering 1,300 degrees Celsius. Hot enough to melt aluminum, but cold enough to allow carbon vapors to condense and crystallize. If 55 Cancri e melts carbon, K2141b melts its entire rocky surface, creating an entirely new hydrological cycle, the cycle of liquid rock and metal. Nearly the entire surface of K2141b is covered by a vast ocean of molten lava, extending hundreds of kilometers deep. But what truly piques scientific curiosity is its atmosphere. Made up of rock vapors that include sodium and silicon oxide gases. There, the rock vapor condenses and forms a relentless rain of molten rock and metals that falls back into the magma ocean. This planet is constantly being eroded and recreated by its own materials in an unceasing, brutal cycle. WASP-12b is a hot Jupiter spiraling toward its doom. It orbits its parent star at such a close distance that tidal forces have stretched it into an egg-shaped form. Based on the measurable rate of mass loss, we now have a terrifying timeline. WASP-12b will be completely consumed by its parent star in just a few million years. This planet was one of the first exoplanets discovered, but it doesn't orbit a normal star. It orbits PSR 1257 plus 12. A pulsar, the core of a dead star, spinning rapidly and emitting powerful electromagnetic radiation and gamma rays. The existence of PSR 1257+12 and other pulsar planets has led scientists to propose that these planets formed from the leftover matter after the star's explosion. Much like a phoenix emerging from the ashes of its mother star. But how do the materials that make up these planets withstand the continuous molecular degradation caused by such intense radiation? V391 Pegasi b represents a feat of physical resilience. It orbits a dead red giant star. When its parent star expanded into a red giant. It began to engulf the nearby planets. V391 Pegasi b was within the range of this destructive expansion. However, through a mechanism not yet fully understood, the planet survived the melting and evaporation of its outer gas layers and stabilized in an orbit far from its parent star. These death worlds reflect the fragility of Earth and the endless complexity of the universe. Mars is currently the focal point of our exploration efforts. Not only because of its proximity, but also because it serves as the first biological laboratory to test our ability to recreate life in a near-deadly environment. Projects like SpaceX's Starship have redefined the concept of space travel, shifting from single missions to a reusable model capable of transporting dozens of people and supplies. The ambitious goal is to establish a base on Mars within the next decade. However, the biggest challenge isn't in the rocket science of launching, but in the ability to withstand radiation during the long journey. Mars lacks a strong magnetic field like Earth's, meaning future inhabitants would face radiation levels many times higher than what we experience here, directly threatening their DNA and significantly increasing the risk of cancer. We have the technology to leave Earth, but we lack the technology to ensure that future generations aboard these ships remain physically and mentally intact. Exploration technology has evolved from merely glimpsing faint lights to the ability to analyze the chemical composition of a world thousands of light years away. The Roman Space Telescope, set to launch in 2027, will utilize coronagraphs to block out starlight and capture direct images of exoplanets. This technology could help us identify geographical features such as oceans or continents on distant planets. The 1967 Outer Space Treaty states that no nation has the right to claim ownership of celestial bodies. However, it doesn't explicitly address the issue of private entities exploiting resources from these bodies. The rise of private companies capable of mining precious metals from asteroids or harvesting water ice on the moon has created a vast legal gray area. One that will require new frameworks to navigate. The principles of SETI, Search for Extraterrestrial Intelligence, have long focused on listening for signals. However, some leading scientists, including the late Stephen Hawking, warned against revealing Earth's location, seeing it as a potential existential risk. The journey of space exploration is a testament to the unrelenting spirit of humanity. It teaches us how fragile life on Earth truly is, and that the greatest challenges we face can only be addressed through cooperation and unity. Located about 750 light-years away from Earth, TESS-2b was discovered in 2006 by the Transatlantic Exoplanet Survey. It is unlike any planet we have ever known. Not emitting light, not reflecting it, but swallowing it whole. TESS-2b absorbs more than 99% of the light from its parent star, making its surface darker than coal, darker than any natural object ever discovered in the universe. Scientists call it the darkest known planet, but more important questions remain unanswered. Why is it so dark, and what is happening in its atmosphere? Some astronomers speculate that the atmosphere of TESS-2b is filled with gaseous titanium oxide molecules, a substance that can absorb light as effectively as camouflage paint. But bolder hypotheses suggest that this planet might possess some form of optical concealment technology, like a planet-level invisibility cloak created by a super-advanced civilization. Imagine a colossal, completely black sphere, like a small black hole drifting through space, reflecting nothing, existing as if it were not even there. Yet twice the size of Jupiter. Such an object, if it drifted too close to the solar system, might go undetected until it's too late. With TESS-2b's eerie atmosphere and the possibility of alien life forms, we can imagine a truly bizarre form of biology, creatures of the dark, as if they stepped out of a Lovecraftian science fiction novel. They would have no eyes, as light has never existed in the place where they were born. Their bodies would be made of light-absorbing liquid tissues, constantly swallowing up every stray photon like the ocean swallowing a raindrop. Their biological structure wouldn't rely on photosynthesis, but instead might use an extraordinary energy source. perhaps from subatomic reactions or some form of space-time oscillation that humanity has yet to discover. They communicate through low-frequency gravitational waves, oscillations. Nearly undetectable, traveling through the thick titanium oxide-laden atmosphere. These sounds would be the planet's underground symphony, slow, dark, and relentless, like a sigh stretching across millennia. They would not need to move as we do when they need to shift. They would fade from their current space and reappear elsewhere, as though not bound by the three-dimensional space we know, a phenomenon humans would call teleportation. Located 489 light-years from Earth, in the constellation Monoceros, there exists a world so extreme that even imagination can hardly comprehend it. J1407b, a super-Earth with a diameter 1.5 times that of our planet, is not a place suited for life as we know it. Was discovered in 2009 by the French-led Kepler Mission using the photometric transit method. This planet orbits its parent star at such a close distance that a year here lasts less than 20 hours. Due to tidal locking, one side always faces the star, creating a fiery hellscape with surface temperatures reaching 2,600 degrees Celsius, enough to melt and vaporize rocks. The strangest feature is J1407b's atmosphere. It contains no water, air, or clouds like Earth, but instead a thin vapor layer of rock vapor rising from the molten surface. Which then condenses and falls as lava rain. Imagine clouds, not of water, but of superheated granite, falling like molten glass from the sky, a lava rain cycle unlike anything seen in the solar system. The dark side of the planet, which never sees light, could be cold enough for its surface to freeze solid like steel. The temperature difference between the two hemispheres could reach thousands of degrees, creating supersonic winds carrying hot rock dust across the planet. J1407b stands as a living testament to the horrifying diversity of planets in the universe and makes us wonder, could any life forms somewhere call such a world home? Imagine silicate creatures, bodies composed of complex silicate minerals, capable of withstanding extreme temperatures and sudden pressure changes. They might directly absorb thermal energy from the molten surface or from chemical reactions between minerals at high temperatures. They might move by crawling or slithering slowly on the surface, or even float within the thick lava flows. They could sense even the smallest changes in temperature and pressure, allowing them to move to more favorable areas. They might have the ability to hibernate for long periods when conditions become too extreme. Perhaps the extraterrestrial creatures on Karat 7b have developed completely different biological mechanisms from any life forms we know on Earth. Hidden in the Centaurus constellation, about 434 light-years away from us, is a planet, or possibly an unimaginably huge object, called J1407b. It was first discovered in 2007 and analyzed further in 2012, when it was found to be the cause of a series of dimming events of the star V1400 Centauri. With an estimated mass 10 to 40 times that of Jupiter, J1407b could be a supermassive planet or a brown dwarf that never fully ignited, a failed star lost between the definition of a planet and a star. What truly makes J1407b a magnificent symbol of the universe is its ring system. More than 30 rings spanning nearly 120 million kilometers, 200 times larger than Saturn's ring system. A structure so grand that if J1407b replaced Saturn in our solar system, its rings would cover almost the entire sky of Earth, resembling the wings of an ancient god. Each ring could contain an amount of material equivalent to hundreds of moons. Some scientists hypothesize that the gaps in the rings may be evidence of moons forming, or even remnants from a massive collision, where an Earth or Mars-sized moon shattered into billions of pieces of rock and ice. These ancient structures may only exist for a brief moment by cosmic standards. Perhaps we are witnessing a fleeting moment in the process of planetary formation, or observing an ancient symbol that has died, slowly fading into the oblivion of space. A strange hypothesis about the life forms on J1407b is that they could be a form of energy or collective spirit, formed from the energy of the colossal collision that created the rings. They may not have a specific material form, but instead exist as complex energy fields interacting with ice particles. They may harness geothermal energy from inside moons, or absorb chemicals from frozen groundwater veins. They could develop specialized sensory organs to navigate the darkness and detect prey. In this scenario, we could imagine creatures similar to deep-sea organisms on Earth, adapted to extreme pressures, eternal darkness, and relying on chemical sources from hydrothermal vents to survive. And like many mysteries out there, J1407b raises a larger question: could such systems be where moons with life might form? Or could those shattered moons have once been home to civilizations, consumed by the death ring? Amid the endless darkness of the cosmos, the Trappist-1 system captivates, not just by the number of its planets or their position within the famed Goldilocks zone, but by the relentless challenges these worlds face. Most notably, the fierce battle against the intense radiation from their host star, a small yet merciless red dwarf. In its early life, Trappist-1 unleashed powerful bursts of ultraviolet and X-ray radiation. Streams of energy so fierce, they didn't merely illuminate, but tore through everything in their path. Though invisible to the human eye, these rays wield devastating power over planetary atmospheres, especially targeting light gases like hydrogen, the fundamental building block of primordial atmospheres. Like a cosmic storm stripping away fragile clouds, the star's radiation relentlessly blows away molecule by molecule, slowly robbing these planets of what might have been a protective shield for life. This phenomenon, known as hydrodynamic escape, a clinical term masking a dramatic cosmic struggle, reveals the sheer force of nature beyond control. After hydrogen layers are stripped away, a secondary atmosphere may begin to form a denser, richer cloak composed of carbon dioxide, water vapor, and heavier gases. Before us lies a stunning tableau of destruction and rebirth, death and life intertwined, raising urgent, haunting questions. Can this secondary atmosphere truly protect and nurture nascent life? In our quest to unravel the vast mysteries of the cosmos, telescopes serve as humanity's guiding eyes, piercing through the darkness to reveal worlds far beyond our reach. Among these cosmic treasures, The Trappist-1 system, with its 7 planets orbiting a modest red dwarf star, has become a focal point in the search for life beyond Earth, a crossroads where science and philosophy intertwine. The Hubble Space Telescope began this journey by scrutinizing the planets Trappist-1b and 1c. Its observations revealed an absence of thick, hydrogen-rich atmospheres enveloping these worlds. Instead, what lay beneath was a barren, rocky surface cold and isolated beneath the faint glow of their star. Yet hope flickers within the Goldilocks zone, the region just right for life. Trappist-1e emerges as a promising candidate, potentially retaining a secondary atmosphere rich in carbon dioxide and water vapor, forming a protective shield that could nurture life. These discoveries transcend mere scientific data. They whisper tales of resilience and adaptability, of life persisting against the harshest odds. Trappist-1e, a planet in the Goldilocks zone of the Trappist-1 star system, stands out as a prime candidate for harboring life. But what makes this distant world a potential cradle for life? And could life here be anything like ours? Unlike what we know, life on Trappist-1e may not be based on carbon, the fundamental building block of all life on Earth. Earth is just one example in this vast, endless universe. And on a distant planet like Trappist-1e, life may have evolved using entirely different elements, such as silicon or sulfur instead of carbon. The beings on this planet might not have solid, bone-like structures like ours, but instead could be composed of flexible, adaptable components capable of reshaping themselves to fit their environment. Furthermore, these life forms could exist as plasma or gaseous entities with the ability to continually morph their physical structure. This makes them not just survivors, but masters of environmental adaptation, capable of protecting themselves from harsh factors like the intense radiation from their star, Trappist-1. If they lack senses like ours, how might these creatures perceive the world around them? Life on Trappist-1e may not rely on light to sense space. Life on Trappist-1e could potentially use magnetic fields to navigate and interact with objects, creating a world that human senses cannot grasp. This form of connection might completely alter our understanding of life, as these creatures wouldn't need light or sound to see their world. Moreover, the adaptability of life on Trappist-1e could surpass anything we know. their bodies might regenerate or repair themselves when damaged. Not through physical means, but via biological or electromagnetic mechanisms. They could thrive in environments that are far harsher than Earth, where intense radiation and extreme conditions might force their bodies to evolve or regenerate to survive. Their civilization might not resemble anything we're familiar with. Instead of relying on mechanical technology like us, they could develop biological or electromagnetic technologies, systems that don't depend on physical tools, but still sustain life and foster development. Trappist-1 opens profound questions about life and extraterrestrial civilizations. Could life exist in ways we've never imagined? Amid the millions of stars scattered throughout the Milky Way, there is one special star known as Kepler 452, a small, distant point of light located about 1/800 light-years from Earth in the Cygnus constellation. But don't let the distance deceive you. This star holds the key to one of humanity's most fascinating journeys in the search for extraterrestrial life. It was discovered by NASA's Kepler Space Telescope, tasked with hunting for exoplanets outside our solar system using the photometric method. Kepler 452b is a planet orbiting the star Kepler 452, making it an exoplanet within this system. It is the first planet ever discovered to be located within the habitable zone of a Sun-like star. This special zone is where liquid water, living conditions, and biological processes could potentially form, just as they once did on Earth. Kepler 452b is about 60% larger than Earth, with twice the gravity. If humans set foot on it, every step would feel heavier. What would happen if life not only emerged but evolved here before Earth? Could a civilization have once thrived on this planet and now watches us, as if gazing at a past version of themselves? Or is Kepler 452b merely the silent remnants of a dream that perished millions of years ago, leaving behind faint signals, structures no one understands? As we gaze upon Kepler 452b, Earth's twin, a great question arises. Could life have taken root there? With conditions similar to early Earth millions of years ago, we can't help but imagine the wondrous possibilities it might harbor. The surface temperature of Kepler 452b is estimated to range from 22 to 27 DC, much like Earth's climate during the time of the dinosaurs. The perfect temperature for life as we know it to take root and thrive. The gentle warmth, not too harsh, covers the planet like a soft blanket, inviting life from its primordial seeds. Kepler 452b might have a thick atmosphere, the ideal condition for liquid water to persist, fostering a rich biological cycle. With oceans possibly covering most of its surface, a landscape reminiscent of early Earth might unfold. Vast waters, islands, or great continents shrouded in cosmic fog. Could something be rising from the depths, like Earth's first life forms, seeds of a civilization yet to develop? However, all these conditions are just a short step away from the greenhouse effect, one of the most fragile boundaries between a habitable paradise and a second Venus. A planet too close to its star, and life could quickly fall into an irreversible state, like the scorching Venus. Has Kepler 452b managed to maintain its environment? Or has it spiraled into an inescapable cycle? Kepler 442b, like a planet still hiding its secrets, might harbor the potential for a unique form of life, something different from what we know. We only need one more breakthrough to discover that we are not alone in the universe. If Kepler 452b truly harbors liquid water, the essential element for life as we know it, it opens up a grand possibility. Life could not only emerge, but may have developed in ways beyond our imagination. Its gravity, twice as strong as Earth's, would force any evolving life forms to have sturdy, low bodies with thick bone structures and resilient muscles to cope with the constant pressure. In that world, tall creatures would collapse under their own weight. Height would not be an advantage, but a danger. They might not be tall like humans, but short, stable, with strong legs and thick skin to endure the harsh conditions. Their joints would be short and tight, minimizing damage from movement. Perhaps they wouldn't even have bones as we do, but a frame of flexible, durable muscle fibers. The thick atmosphere would not only help retain heat, but also act as a gigantic armor, blocking harmful cosmic radiation. Therefore, if life exists on land, it wouldn't have to hide underground or live nocturnally as life on Mars might. In the oceans, we might imagine a vibrant world of life, bioluminescent sea creatures moving with soft, tentacle-like arms, communicating not through sound, but by flashing lights or electromagnetic waves. Much like Earth's giant squid, but with intelligence that evolved in its own unique way. With light from an older star, Kepler 452b, the light spectrum could have shifted to red or orange. This leads to another unusual prospect. Plants would no longer be green, but might be purple, deep red, or even black, absorbing energy from wavelengths that Earth plants cannot use. The forests of Kepler might be forests of darkness, adapted to gravity and dim light. The thick air and high pressure open the possibility for flying creatures with strong wings, not delicate like birds, but more like insects, moving gracefully in the dense atmosphere. Flying in such an environment is difficult but feasible, and creatures there may have evolved to exploit this as an advantage for travel or hunting. If any civilization ever lived here, they wouldn't speak like we do. For planets lack the physical structures like vocal cords or tongues to produce sound or language. In the thick atmosphere, sound travels slowly and distorted, but light and electromagnetic oscillations are strong. Life on this planet wouldn't be a mere copy of Earth. It would be an entirely different chapter in the book of the universe. A foreign biological language, a type of intelligence we may never have known. In the endless search for a second Earth, we have turned our gaze to many places, from the freezing deserts of Mars to the deadly heat of Venus and to distant exoplanets light years away. But among the thousands of alien civilizations, Kepler 452b still stands out as a promising candidate. Mars, our cold red neighbor, may have once had oceans and an atmosphere. But today it's a barren world, ravaged by radiation without the magnetic field to protect it, and almost no warmth to maintain liquid water. Meanwhile, Kepler 452b, with its temperate climate and the right amount of radiation from a stable sun, seems to have retained what Mars has lost. Venus, the bright mirror in the night sky, is an inferno with a thick atmosphere full of sulfuric acid. If Kepler 452b truly has a thick atmosphere, it could be a Venus not yet risen, where life still has a chance to develop, rather than being burned to cinders. Among the thousands of exoplanets discovered, like GJ1002b or K272e, few planets offer the balance of Kepler 452b. Not too small, not too hot, not tidally locked, and its host star, Kepler 452 AG type of star like our Sun, but older and quieter. This makes its planet stable for long periods, enough for life and evolution to reach a complex level. The journey of exoplanet exploration transcends the boundaries of science, reaching into the deepest questions about our very existence. From identifying potential worlds in the Goldilocks zone, where liquid water could exist, to studying extreme planets with hellish conditions, each discovery reaffirms that the universe is an endless treasure trove of mysteries. Revolutionary tools like Kepler, TSE, and the ambitions of Starship are not just physical instruments. They represent the highest manifestation of human intellect and an unyielding thirst for discovery. However, the most profound value in exploring exoplanets lies not in the worlds we discover, but in the reflection of ourselves. This journey forces us to confront the possibility of survival, adaptation, and, most importantly, the fragility of Earth. Can we secure our existence on this first home before venturing into new homes across space? The future of exoplanet exploration is a blend of science, technology, and moral responsibility. Humanity will continue to seek answers, not only to understand distant worlds, but to shed light on the very origins and limits of our own existence. Thank you for staying with WUFO Space until the very end of this journey through the vast universe. If you found this video interesting and insightful, don't forget to like, share, and subscribe to WUFO Space so you won't miss our next cosmic adventures. Your support means the world to us and fuels our passion to keep exploring the wonders beyond.